Hey folks, welcome back to another video. Today we're looking at question 1863, sum of all subset XOR totals. It's a pretty simple approach that I'll be using for this video. We'll be creating all the required subsets and we'll be XORing each of the elements in the subset. So let's get started. So we'll be creating the subsets using a recursive method. So let's start with that first. We will need a helper method. We need to send the current array and then the index. Let's just go with 0 first. And then you need the current subset. Let's just create like an empty subset for now, new array list. And you need a subset of subsets that will keep a track of all of the subsets. So let's just create that. List of integers. Let's just call it all subsets. New array list. Okay, amazing. And then we'll pass this as well. Awesome. So let's write this method and come back. We can make this private, and we won't really be returning anything since we'll be using all of the subsets from reference, not really by actual passing of the array list. And this is the helper method. Let's add the parameters. So it'd be int of nums, and then we'll have the index, and then we have the current array list of integer as current subset, and the list of integers. This will be all subsets. Okay, awesome. So let's get started. The first thing that we need is a base case. So anytime the index is at the end of the list, we just take the current subset and add it to the bigger list. So if current index is equal to nums.length, what do? We do all subsets that add and we take all of the elements. We create a copy of that, and the reason why we do that is because that particular subset could be used in other computations. So you create a copy of that and add that. I think that's good. And then because there's nothing else to do after you return it, so that it doesn't continue. Right. Once we're done with the base case, we come to the meat of the problem. So for the current subset, you add the element that we have, current subset add nums of I, and then you call it a recursive method on that again. So it'll be helpers of num, current index, so you increment the index by 1, current subset, and then all subsets. Right, so this takes care of the subset that currently has element. The other case that we need to take care of is actually remove the element, the current element that we're looking at, so that subset can be created without that element as well. So what you do is that you just remove the last element because that's the most recently added element. So it would be current subset dot size minus 1. Okay, and then you just send this back again. Amazing. Let's just try compiling this to see if there are no errors, at least in the recursive method. We'll just add this like dummy return just so that it compiles all right. Okay, let's try that again. I couldn't find symbol. It's current index. Okay, let's try again. Okay, cool. At least it's compiling. But we know that the answer is not what we want. Okay, so all of the subsets will be created once we go through the recursive method, and now we have to calculate the total. So there, let's have int res equals 0. So for a list of integer, let's just call it current, and then we take all of these lists from all subsets, right? And once we have the given list, we need to create int current result. Let's just initialize to 0. So for int I in current subset, yeah, let's just rename that so that it's clear. So you need to XOR it, so it'll be current res XOR I. And once you've iterated through all of that, it'll be res, you add the total current res. And once that's done, you would return the result. Okay, let's try compiling this. So the first few test cases are okay. Everything else is okay as well. Awesome. So let's talk about the space and the time complexity of the entire solution. So every single element, you either have a choice of having that in the subset or not having that in the subset. That's where 2 of n comes from, the number of choices to the number of elements. And then we have to iterate this for n elements. So it's n multiplied by 2 to the power of n. The space also is the same because the number of times we're computing it, each one of us gives us a subset, and then we need to store that as well that we use here. Awesome. If you have any questions, please let me know in the comments below. Don't forget to subscribe to the channel and like the video. I'd really appreciate that. Thanks so much, and I'll see you